Hi, welcome to Cybersecure channel. Continuing with CKS Exam Essential curriculum outline, broadly divided into 6 domains, is flashed on the screen. In today's video, we will start the 5th domain, which is supply chain security, having 20% weightage as per September 2024 format. This domain covers minimize base image footprints, understand and secure supply chain, and perform static analysis of users' workload and container images. Today we will be discussing minimizing base image footprint. First, let's talk about why minimizing the base image footprint is so important. Here are the key reasons. First of all, improve security. Smaller image having fewer components, which means fewer vulnerabilities. A smaller attack surface makes it harder for attacker to exploit your container. The second is faster build and deployment. Smaller images are quicker to build, push and pull. This speeds up your CI/CD pipeline and reduces the deployment time frame. The third is reduce resources usage. Smaller images consume less disk space and memory. This is especially important in environment with limited resources like Kubernetes cluster. In short, minimizing the base image footprint make your container safer, faster, and more efficient. Now let's have a quick recap of what is a Dockerfile. A Dockerfile is a text file that contains a series of instructions for building a Docker image. These instructions define the environment, dependencies, and configuration needed to run your application. Think of it as a recipe for creating a container. Let's discuss some instructions of Dockerfile. The first one is from. The from sets the base image and initializes new build stage. Name can be given to the build stage using the as. The argument define variable that users can pass at build time. In the example, the argument instruction is used to avoid interactive prompts during installation. The work directory set the working directory. The run instruction create new layer on top of the current images and execute any command and install dependencies. The copy instruction copies the application file from the host machine or the base image. The expose instruction is used to expose the application pod and describe which pods your application is listing on. The user instruction is used to set user and group ID for subsequent command. It ensures that container runs as non-root user. The entry point allows you to configure a container that will run as an executable, and CMD instruction define the command to run when the container starts. Together, these instructions create a secure, efficient, and well-configured Docker image. Understanding these instructions is crucial to ensure your container are secure by following best practices. Here are some best practices for creating a secure Docker image. The first is to use minimal base image. Always prefer lightweight images like Alpine or DistroLess. Avoid large general purpose images like Ubuntu unless absolutely necessary. Leverage from multi-stage builds. This separates the build and runtime environment to include only what's necessary in the final image. Remove unnecessary file and packages and clean up temporary files, caches, and unused dependencies. Don't run the container as a root. Use a non-root user to reduce the risk of privilege escalation attacks. Make the file system read-only. It prevents modification to critical directories like etc. Remove shell access. Use distroless image or delete the bin sh to reduce the attack surface. And finally, use tools like Trivy to identify and fix vulnerabilities. Now, after understanding the Dockerfile, instruction, and best practices, let's combine all the knowledge together and make a secure Dockerfile. As you can see on the screen, it is a multi-stage build. The first stage uses Ubuntu to install dependencies and compile the Go application. And the second stage uses Alpine, a lightweight base image, for the runtime environment. We have we clean up the temporary files and unused dependencies using apt get clean or rm-rf. We also made the etc the directory as a read-only directory. We created a non-root user as well, and we deleted all the binaries in /bin to remove the shell access. The final image only include the compiled application and necessary runtime dependencies, making it small and secure. Now, let's have a practical demonstration. We have a Docker file. It is a single stage, as you can see. The base image is Ubuntu. After installing dependency, we copy our application application file from host operating system into the container and run it. Then we have a simple application on host operating system that just displays the username and ID of the user running the application. Now let's build the Docker file and create an image with the name base image. The installation will take some time. Let's wait for the installation to be completed. The theme is that we will create first single stage image, the base image, and we will see the size of that image. Then we will leverage the multi-stage Docker file to create a thinner and efficient container image, leaner container image. And as you saw in the Docker file, there was no security enabled. The application will run as a root. There is no restriction on any directory. All directories are available for modification. And even /bin directory is there, so the user can also have a shell access to the container. We will enable all of the security features step by step in order to demonstrate the effect of each and every instruction. And then we will compare the two images. The first one, the base image, and the refined image that we just created by enabling some security features and multi-stage build. Now our first stage is completed. We have created a base image. Let's see after build we can see the image through Docker image ls. As you can see, the size of the image is 654 MB. Because it was a single stage build, let's have our first target to reduce the size of this image through a multi-stage build. Now making the changes to the Docker file. First of all, defining the runtime environment and using the Alpine, which is a lighter image, and giving the exact version number as per the security best practices. Then defining a group, user, and home directory of the user using the run instruction. So that our application now will run through the non-root user, that is the app user. Now copying the files from the base image to the home directory of the user we just created. Now after copying, running the application from the home directory of the user, using the username app user through user instruction, and then giving the command to the exact location where the application has been copied. After setting the Dockerfile, let's move on to build it with the name refined image. Now let's check the image. Now the new image, the size of the new image is 7.6 MB as compared to 654 MB of the base image. Now when we run the base image, it runs with the root user. But when we run a container with the refined image, it runs with the non-root user that we just created in the Dockerfile. Now let's get the shell access of the container using the refined image. Now creating a container and getting the shell access of the container using the refined image. Now we can list all the directories. Now we can see that the etc directory has some additional write permission. We want to deny the writing anything to this directory and make it a read-only directory. Let's make the changes to the Dockerfile again and make the etc directory as read-only to the user. After the refinement in the Dockerfile, let's build the image again, now with the name of refined image2. And now using it to run a container. Now again getting the shell access to the container and checking the permission of the etc directory. Now we can see that it is a read-only directory now for the user. So the user cannot make any changes to this directory. Our next step is that we want to remove the shell access of the user to the container. So for this purpose, let's make some changes in the Dockerfile and remove the binaries. It will enable no shell access to the user. Now removing the binary directory. And again building the Dockerfile. And running the container. Now we can see that we are not having a shell access to the container. Let's check it. Yes, so we don't have a shell access to the container now. Now let's have a recap. The best practices for minimizing the base image footprints are to use minimal base image like Alpine or Distroless, leverage multi-stage builds, remove unnecessary files and packages, don't run the container as a root and use a non-root user, make the file system read-only, remove the shell access, and scan images regularly for the vulnerabilities. That's it for today's video. If you found this helpful, don't forget to like, subscribe, and hit the notification bell so that you don't miss our next video. And if you have any questions or topics you would like us to cover, drop them in the comment below. Thanks for watching again, and I'll see you in the next one.